So let's have a look at something different, eh? Secure hash algorithm in 86 assembler language, NIST FIPS 180. So you've got input, output, and you've got the process basically. So pretty standard for everything, computer wise, electronics wise, modular electronics, inputs, process, output. So your input is a message in blocks of 64 bytes. Each block is 4 bytes, and the size of the message can be up to 2 to the power 64 bits. Your output is your secure hash algorithm, 256 bits or 8 words. To pre-process the message, what you've got to do is pad it out, pad the input out, so that the length is a multiple of 512 bits. Then you divide the message up into a sequence of 512 bit blocks. And then you calculate your hash, you set an initial value, you pass the blocks to the hash function one at a time. And then for each block, you generate a 64 word message array, and then you use the message array and the current hash value to compute the next intermediate hash value, and then you keep on, get the next block and repeat. So you keep going. So the structure of the code for x86 assembler language, we use a dialog box structure with text boxes and buttons. It's a top-down programming structure. So basically, we get invoke, get module, handle, and then that passes as an address in AEX. So we get that, and it passes as a. Then we invoke dialog blocks param with the AEX and a pointer to our dialog procedure. Then we create our dialog procedure and we get the messages, which is initialize dialog, look for a command message, close message, quit message. So following the top down, we generate this one first. So the initialize dialog is basically what we're doing is we set the dialog text item, the input to the initial text, which will be a description of what you're supposed to do, and then which you can clear, and then we've got set dialog text for the output window, which will be a 0, nothing there. So that's just 2 easy instructions for initialize dialog. Your command will be 2 buttons. So we've got a button for the hex. So you can put in hexadecimal numbers that you want a hash, or you can have a button to hash text. So that's pretty straightforward. Then you jump down again. We do this one first, top down. So what we do is we get to process the hash for the hexadecimal numbers. All you do is get the dialog item box text, the length from the display, the input, and then you call string to message buffer So what you're doing is you're copying the string that you've got from your dialog box into your message buffer ready for hashing. Then you call a subroutine or a procedure, compute hash, then you print the hash, and then once you printed the hash, you redisplay it in the output window so that you can see it. So it's pretty straightforward. And then you've got the text is just the same. You get the dialog item text. Then you've got a different one, text. You've got a text to message buffer, so you've got to put the text instead of the hexadecimal numbers into the message buffer, compute the hash, print the hash, display the hash in the dialog box window. So what we want to do here is reset the message buffer. So what you do is you get the address of the message buffer into EDI. You set your counter to 0, which is CX. You start your loop. You put a 0 into the buffer, into the message buffer, pointed to by EDI. Increment EDI, increment your counter, compare it as the message length. Have we reached the message length yet? No, loop back and clear the whole buffer. Pretty standard stuff. So now you've got the text to message buffer. It's an input. The input is a string, a text string, and we're going to copy the bytes into the message buffer. So we use ESI to get the address of the display and the message pointer to the message in EDI. We set the counter. We get a byte from ESI into AL. We compare it with 0. If it is 0, it's the end of message. Jump if equal to done. If not, it is a valid text, and we put AL into our EDI, which is the message buffer. So we've taken one from the display buffer, a byte from the display buffer, and put it into the message buffer. Then we ink the display buffer, ink the message buffer, ink the counter, the length of the message. Then we compare the counter with the message length. Have we copied all the message yet? No. Jump back. And that's it for now. And then we'll get onto the hash algorithm later. But that should be enough. It's pretty simple and straightforward. And it's good fun. But you've got to follow the top-down structure. It makes it a lot easier. So we can get this to